Now, concrete has done some amazing things in the world, like transporting clean water or keeping water out of certain areas. But it's gone just a step too far. It's urbanized to the point where you have so much concrete and asphalt and impervious surface area that now every time it rains, that rain hits the pavement and it becomes runoff immediately. There are these unintended consequences on top of the fact that it is one of the biggest contributors of CO2 in the world. Well, it's a new type of concrete that is made from really three main ingredients. The three ingredients really are reclaimed. It's these three main ingredients that then go in certain proportions, create a chemical reaction where you get really strong material, you get this high durability, but you also get, without getting too technical, hydrates go off during the reaction and it creates permeability.
Welcome to Mindful Businesses, and I'm your host, Vidya Iyer. In our podcast, we bring to you businesses that are mindful in their practices and processes. A mindful business adopts and employs sustainable social, economic, and environmental practices. Today, we talk with Greg Johnson, co-founder and CEO of AquiPor, climate adaptation technology for the built world. He joins us from Spokane, Washington. Welcome, Greg.
Thank you for having me. I'm excited to be here.
Concretization is said to be a silent killer, a major environmental problem worldwide. What is concretization and how would you define it?
Concrete is really the building block of modern civilization. It's gone into building, our buildings, the structures around us, water infrastructure, even underneath our streets. You think about the pipes and the tunnels and the tanks. And then think about all the sidewalks and the alleyways. It's everywhere. It's a ubiquitous material. The problem is the main ingredient that goes into making concrete is Portland cement. And the process of making Portland cement is responsible for like 8% of the world's CO2 emissions every single year. So you have this very useful material, but we've made so much of it and it's made in a process that's very injurious to the environment. It's a problem that people don't really think about. In a sense, it's kind of this silent, destructive material.
Portland cement and all cement use limestone, which is heated up to thousands of degrees. In the process, it releases the carbon dioxide into our atmosphere.
That's exactly right. You're on it. And that doesn't get talked about much because that's a huge industry. And that's an industry that really does, in a sense, power the world because we need concrete in the world. At AquiPor, one thing that we've looked at is, we're really focused on a new type of concrete that can help cities manage stormwater. So our material is permeable. It allows water to go through it. That's one key aspect of the material. But the second piece of it is there's a whole new technology that we utilize that does not use Portland cement. And so it's a whole new way now to make concrete that is inherently low carbon, and it utilizes reclaimed materials that are already out in the world. So we don't need to go and mine a bunch of limestone and put it in a kiln up to 2,000 plus degrees Fahrenheit, nor take it into a grinder to get clinker material. It's just a whole different process that we consider to be inherently green.
Growing up in India, even in a big city like Mumbai, we had buildings which were made of concrete, but our yards had either just mud or some grass over it. Pretty soon, everybody wanted to park their cars in the building compound, and they concretized the compound, the building walls. In those days, we sort of thought of it as progress, but in fact, the silent killer had other problems that we are seeing now 20, 30 years later.
You're absolutely right. And so there's I call it an unintended consequence to concrete. Now, concrete has done some amazing things in the world. It has helped, again, I go back like transporting clean water or keeping water out of certain areas. It's done some amazing things actually for the health of humanity, but it's gone just a step too far because, to your point, I look at I'm looking out the window of my office right now, even in downtown Spokane, Washington. This is a small city, but it's urbanized to the point where you have so much concrete and asphalt and impervious surface area that now every time it rains, that rain hits the pavement and it becomes runoff immediately. Now you have water issues. You have natural rain that should be going back into the ground to replenish groundwater, now does not get back into the ground. There are these unintended consequences on top of the fact that it is one of the biggest contributors of CO2 in the world in terms of industry. There are now different ways to look at this, but what we're trying to do is let's quote unquote have our cake and eat it too. We can still provide that paved, usable space, but let's do it in a way that gets water back into the ground naturally and doesn't produce all this CO2 when we produce the material.
What is the rate of concretization with so many of the countries who are still growing, developing, building better roads and better connectivity? What is the rate if there's a percent compared to, say, 10 years ago, 20 years ago? What is the rate of concretization or even the use of a cement?
I've seen numbers all over the board. I've seen a number that says 4.4 billion tons of cement is produced each year, which equates to, I need to find the citation for these, but over 1 billion tons of physical concrete. That is a huge amount. And let's also think about when there's construction, retrofit construction, where you have existing concrete structures that need to get demolished to rebuild certain structures. That material then ends up going where? Into the landfill. And so there's a huge amount of waste that's produced, from this leftover material. And so it's a big number. It's a number that is unsustainable, quite frankly, if we're going to continue to make concrete in the same way that we're making it today.
And the other side effect that I have read about is concretization almost makes our world like a kiln. It just increases the overall atmospheric temperatures, reduces the day and night temperature differences, which are required for various crops to thrive and grow, and maybe even rainfall. So the problems are not only the impermeability, the CO2 in our atmosphere caused by cement, but rising temperatures.
It's a huge issue, and I'm glad you hit on this. Urban heat island is I won't say a silent killer, but it is a very big problem in densely urbanized areas where temperatures can fluctuate 20, 25, 30 degrees in the dense urban area. So think of a downtown Los Angeles or a name the big city where that is definitely an issue. And there are some, initiatives or some pushes now to obviously go more green, so you have more green space in cities, which I love. I think that's very much needed, so you can help reduce urban heat island effect. But at the same time, there still needs to be that usable space, that paved areas that allow you to move humans and vehicles and things of that nature. It'd be great to say that we're just going to do away with that and we're going to do away with all the vehicles, on Earth. But the reality is, humans are not great at necessarily changing our ways. Again, that's something that we've looked at is, well, can we now make a material that is inherently sustainable, that helps solve the urban heat island effect because it's permeable? Again, it's a low CO2 type of solution.
So we talk about growth, and from it, we now talk about green growth. What exactly would be green growth? Would it be the use of nature or preservation of nature or using materials from nature?
I think all of the above. I think there needs to be the right balance of using nature-based design with your harder urban design. My view or my vision for green type of growth would be replace all the materials to the best of your ability that are not green, that have been around for over 100 years, concrete, for example, with a new greener type of concrete, greener type of material, and augment that now with nature-based design, more green space, more tree canopy, rain gardens, things of this nature. And I think you can combine those aspects to make our cities much more sustainable. And I think that needs to be the focus as we move forward, especially in the United States with the passage of this new infrastructure spending bill.
You talked about rain gardens. What are rain gardens?
I guess they can take on a different meaning. In the Northwest, here in the Northwest corner of the United States, rain gardens are used quite a bit in dense urban areas. And what they are basically little swales or little pockets of gardens, basically, that are implemented within the built environment. So along the side of a street, sometimes you'll see them in the middle of the street as a median, where you plant native plants or flowers and you divert stormwater runoff to these little rain gardens that then naturally treats the stormwater. And you use, again, native plants that are easy to maintain, but you get that sort of green aspect. And it's a way to manage stormwater naturally and, again, just get more green space in our cities.
I've seen it in some small towns in Indiana, like Lafayette, where we lived prior to this. They actually had done away with the storm sewers. And like you said, they had put swallows with native plants, which in some ways also performed as some of the plants did fight to remediate. They cleaned up the oils, the runoffs from the road, and let out cleaner water into our waterways. But they also increased the water table to some extent. Why is that important?
It's very, very important. Again, and I think there are three factors that contribute to some of the water issues we're seeing in large cities throughout the US and really throughout the world. Because of population growth and urbanization, we are depleting groundwater supplies and aquifers at a completely unsustainable rate. And so now when we pave our cities over with concrete or asphalt and it rains, that rainwater is engineered to go to a big underground conveyance system that then goes to a treatment plant. And then that water gets treated and it's discharged into a clean water body, which on its surface seems okay. It's like you're cleaning this water and you're sending it back out to a river or the ocean. The problem is these systems are now getting overwhelmed because we're getting larger, flashier rain events in less amount of time. And so now sewage and wastewater is ending up in our clean waterways. But besides that, even the clean water that ends up out there, it's not getting back into the ground to replenish groundwater. And so there are three issues. I think our gray water infrastructure is outdated. Our cities have urbanized with so much impervious surface area that water doesn't get back into the ground. And then climate change, quite frankly, is bringing these rain events that are sudden and they hit very quickly. Without replenishing groundwater, you actually see, in Mexico City is a great case study on this, the city is sinking. It's just been unnatural groundwater extraction is happening without replenishing groundwater, and that's a huge problem.
So let's talk about your solution, AquiPor. What is it made of?
Well, it's a new type of concrete that is made from really three main ingredients. One, without getting into some proprietary detail, one of them is an industrial mineral. It's one of the most abundant minerals in the Earth's crust. We combine that with a aggregate that has very fine feldspar. So feldspar is a mineral and we need the aggregate to be very fine. And then the third, ingredient would be a catalyst, which we source from agribusiness. The three ingredients really are reclaimed. Okay, so these are materials that typically go into other industries and they have waste piles of this leftover or excess material all over the world. And we can use that waste literally to make our concrete, and there's a lot of it. It's these three main ingredients that then go in certain proportions, create a chemical reaction where you get really strong material, you get this high durability, but you also get, without getting too technical, hydrates go off during the reaction and it creates permeability.
Do you use a lot of heat to make this product?
Not a lot of heat. In fact, the last step of the process is a very low heat sort of finishing process where you want to get the material up to about 200 degrees. And you do that for an hour, and then it's ready to ship. It's ready to go out to a job site. The other thing is, in warm climates, you wouldn't even need to do that. You could just keep it out on the yard for, say, 10, 20 days. And, in 90 plus degree weather, that reaction automatically takes care of itself, and then it'd be ready to go. The final step in the process, that heating process, is kind of what helps finish it and facilitate high permeability rates.
Are you the inventor of this product?
No, our story's different. I'm not the inventor. Our inventor is a material scientist who has kind of a background. He's a professional engineer, but also has a background in mining and mineralogy. And the way this all came together is I saw a market or a need for permeable solutions way back when I was actually working a little bit in the real estate development world. And real estate developers or commercial property owners would need to, because of regulations, put on some, in a new project, a stormwater facility to be able to manage stormwater on site. And I always thought, if you could just make a material that would take the place of traditional pavement that actually solved the stormwater issue at the same time, there'd be a big market. And so I started my first company along with my co-founder, I think as far back as 2009. And we learned a lot about the market, and we were importing a product from overseas. There are huge issues with that was a lifetime ago, separate business model. But around the same time, we met our inventor who was working on a cement technology. And we kind of came together, and it was a meeting of the minds, us on the market side, him on the technical side, and AquiPor was born.
And what is this inventor's name?
Matt Russell. And he is actually the CEO of, I'd consider it our sister company, the concrete company called BWIGC Inc. And IGC stands for Inherently Green Concrete.
So you take these 3 materials, finish it off with low heat. How strong is it? Can I use it to build my basement?
Yes, potentially. It would be strong enough for foundations. The theoretical strength of this technology is above 20,000 pounds per square inch, compressive strength.
And what is concrete's?
Concrete is around, 5 to 8,000 PSI. Ultra high strength concrete can get up to 20,000 plus PSI. But it's very expensive to make that way, and it's, again, chock full of Portland cement. This is an invention that there's actually papers out on it, very generally, not talking about the specific material, published, technical papers about the theoretical strength. But what it comes down to is the size of the material. So the smaller the material is, the more rigorous the chemical reaction is.
Smaller in terms of the molecules being smaller.
Yep, if you can get it down to the molecular sort of almost dust particles, you're going to get extremely rigorous chemical reaction in a very strong material. That's something right now that we're working on is as we source the materials, they're coming in all different sizes and gradations, and being able to then work with our supply partners to get it sized at the right size.
Like porcelain, with such a fine clay.
Yes.
Is much stronger than your red earthenware extruded to a very, very thin cup, which has all the strength of a very thick earthenware cup.
Yep, same idea, same concept.
So we talk about your product. Does it by any chance capture carbon from the air? Is it possible that it is able to capture and sequester carbon?
We are working on a mixed design that sequesters carbon, but we're doing that through biochar, which is basically biomass that goes through this pyrolysis process. And the higher the carbon content, obviously, the more sequestration we can claim. And so there's one product that we can put a large amount of biochar in because we don't have to meet quite as high as strengths. And so in that particular product, we definitely will look to sequester. There's a big market for that too, obviously.
And how long does it take to cure? For instance, concrete needs so much water to cure it. It takes so long. How long does your product take to cure?
It's short in comparison to normal concrete. So we can get to higher release strengths. And what I mean by that is being able to take it out of its form and say stack material, palletized material in as little as 1 hour. So anywhere from kind of 1 to 3 hours, it will set up and we can start doing that. Concrete, you need at least a day, and then concrete gets to its full strength after 28 days. And so there are huge possibilities with this concrete technology as it pertains to productivity gains for manufacturers. So if they're stripping material out of forms and they can get it on a truck or get it to a job site in a fraction of the time than normal concrete, obviously they're going to have better productivity. And so that's just another, I think, key aspect of the performance characteristics of the material.
The market for your product is so huge. What is your business model? How will you tackle it?
That is the $1 million, or if not $1 billion question. We've looked at kind of two ways of going about this. I actually think AquiPor is going to become an engineering, procurement, construction management business. And so in other words, we're going to be a projects company that goes out and garners sort of these larger green infrastructure projects. And we will work with, design engineers to stamp the design and the engineering concept. We'll procure the material because we don't want to manufacture it. We want to license or franchise out the manufacturing and oversee quality control of that material and then oversee final construction of these projects. The other kind of secondary business model or thought process is just to license the technology to, say, paver manufacturers. And so they can make a product with AquiPor inside because they're already in a lot of those markets. They have channel partnerships. And then we would just take a percentage of every product sold that uses our technology.
I don't know if you had a chance to listen to one of our episodes, Ferroc. It's a researcher in the University of Arizona who takes iron and mixes it with silica flume, and it naturally becomes a form of cement when it's mixed with aggregates. It's very, very strong. And he had a similar struggle because Portland cement is the big giant in the world. It's really hard to take them on. So he actually has started making planters, art objects, just to be able to get his projects going in some way, because it's been hard to break in and convince people in the construction industry to say, hey, here, take my product, do away with Portland cement, which you've been doing for about 150 years, since 1875. And you start using my product. I promise you it'll be the greatest product, very green, very strong. How will he convince people?
That's very difficult. And he's doing the right thing, though. I think you have to find different niche products and different niche markets to get something like this out into the market and get traction, because you're exactly right. I mean, the cement industry is very entrenched. They have staying power, obviously. They're huge. And I think for us, we are not competitive in any way, shape, or form to them because what we're doing on the permeable side, they've already tried permeable. They're not interested in furthering that technology because, frankly, it's not very good what they've done in the past with pervious concrete and some of these other approaches. And so I think in a sense, we can augment what they're trying to do. And that's our approach. I mean, we don't want to go out and necessarily compete with anyone. I think what we have is very unique, and there's a niche market and a niche need for what we're doing.
So what makes your product permeable?
Again, it's that chemical reaction that creates these chambers throughout the material, and they're very small. It's also, we're trying to figure out the nomenclature of the material too, because there's such a thing as porous concrete. There's permeable concrete. Permeable concrete is simply pavers that use gaps in between them to filter water. And I mean, really, it's the gap that's permeable, not the concrete. So what makes our material permeable really is just this chambers throughout the material. There's a lattice where water gets on the surface and it literally goes through the material directly down to the ground. It's just chemistry.
And those chambers don't get clogged.
Well, over time they may. What we know, we've done internal tests. We know that the pores are submicron. We also know that the vast majority of particulate matter in stormwater is typically above 5 microns. And so we will filter onto the surface the vast majority of those particulates. Over 5, 10, 15 years, if you don't maintain the product, it will probably clog up. So you still need to maintain it with vacuum sweep or a street cleaning mechanism. But it certainly lasts a lot longer than pervious concrete or what's been out there in the past.
So are you saying that we could have bike paths which don't collect water? You could ride your bike on it because the concrete or your product, AquiPor, would just let the water go pass through.
You're exactly right. So bike paths, alleyways, parking lots, sidewalks, there's a lot of different applications. We don't necessarily want this in the street, taking on all that heavy vehicular traffic. And mostly that has to do with the subsection would be a very expensive engineered design to do that. And we also think it's a little overkill because we can use this material adjacent to the street or adjacent to areas that get a lot of traffic, and you can funnel stormwater to the material.
Do you have a patent on this?
There is a patent pending on this, and then we have a first generation patent achieved on a very similar approach, but it uses much higher temperatures to get, it's a sintered technology, and it uses much higher temperatures to get permeability and strength. So this newest technology is the evolution, basically. But what we've done, and part of our sort of IP protection strategy, has been to continually patent around that first technology.
Is the product available in the market right now, or when do you plan to launch?
Not quite yet. We're in very small scale pilot manufacturing right now. I could see us having commercial product by the end of the first half of this next year. And that will be, subject to some testing and standardization that we're very confident in, but we have to actually go through and get the third-party tests done. And what's unique about the material is there are all these standards for permeable concrete and traditional concrete, but we almost have to work with the powers that be to come up with our own standard to test and standardize the product. So that's going to take some time and some process, but we're in the midst of that right now. So we're hoping by middle of next year, we're ready to go.
So you will not be a manufacturer. You would license your technology and set up close to consumption, maybe, or raw materials to make the project a go.
That's how we're setting it up. Where we're doing our pilot manufacturing here in Spokane, we have a precast concrete manufacturer who's a partner. They understand the business well, and I think they could potentially be the group that goes out and finds these other precasters and other manufacturers to be able to do that. But the idea is set up manufacturing as close to the end market as possible and as close to the source supply line as possible. And that's all very doable. I think the key is you don't want to be trucking material halfway across the country, and you want to be able to utilize local labor forces, local material, local manufacturing.
You are in the process of raising funds via startengine.com. Tell us, what was your goal and how much you've raised?
We just actually finished that recent crowdfund, and the goal was to raise $3.93 million. We finished at just over $1.5 million. So we came up a little short there, but we're actually doing an extension round right now to try to raise closer to $5 million. I think right now we're in the midst of needing to continually raise until we get this launched and get to market. In a sense, it's the nature of the beast. We've liked crowdfunding because it has allowed everyday retail investors the chance to get in on the ground floor of something that we think will have a great impact. And I think what we're noticing is people are more conscientious now about what they're investing in terms of, does this do good in the world? Could this make an impact? lasting impact. And so there's definitely a cohort of those type of investors that this has resonated with, and we want to continue to go that route.
Wishing you all the best. Thank you so much, Greg Johnson of AquiPor, for coming on Mindful Businesses.
Thank you so much. It was my pleasure. Keep up the good work too, spreading the good word of companies and innovators trying to do well in the world. So I appreciate it.
Thank you again. You're listening to Mindful Businesses. We would love to hear from you. Send a voice note with your questions or comments to info@mindfulbusinessespodcast.com. Subscribe, rate and review us on Apple Podcast. If you learned a thing or two from this episode, share it with one friend. We recorded this podcast in Buffalo, New York. Theme music was composed by Tatum Gale. Our marketing assistant is Roseanne Korean. Our advisors are Jim Stone and Anupama Pastrija. This is Vidya Iyer with Mindful Businesses.